Hi, welcome back everybody. In this section we're going to continue to work with the operations on sets that we were working in our last lesson. If you haven't already, make sure that you watch the previous lesson, the one before this, on operations on sets so that you can be familiar with complements, unions, intersections, and other concepts related to sets so that this lesson makes sense. We're going to work with Venn diagrams now, and I've got a Venn diagram on your screen uh, that is sort of self-explanatory. We've got three categories of foods. We've got healthy foods, tasty foods, and affordable foods. And you can kind of see that the intersection of some of those sets are a little bit more narrowly defined. For example, junk food. It's affordable and tasty, but not really healthy. It falls outside of that circle. Fruit is healthy and tasty, not always affordable. I love grapefruit. They're kind of expensive. Healthy and affordable vegetables, but maybe not so tasty. Here you go. Here's an extra credit opportunity for you. If you email me the food that you think belongs in the center of that Venn diagram, that is to say healthy, tasty, and affordable, you email me the food that you think should be in the center of that Venn diagram, and I will throw 1 point as an extra credit point on your next test. Go ahead and do that, and then let's get started. Okay, so for starters, the visual representation of the universe. We represent the universe with a big rectangle, and that contains all of the elements that are available for our subsets. And that's the starting point for all Venn diagrams. Now, a set within the universe is represented typically by a circle, and we can call that circle A or B or C or whatever the name of the set is. A proper subset, such as the one shown here, A is contained in B and is shown by the little symbol that kind of looks like the letter C or a U turned on its side. That means that A is completely contained within B and in fact has fewer elements, is smaller than B. So on the Venn diagram we would show that the set A is a circle inside of the larger circle or the larger set B. Now, of course, A and B don't need to be subsets of each other. They can be separate sets. And as we saw in our previous lesson, the union is this set of all elements that are in A or B. So I've represented that in red here. That's the combined region of all the elements that lie within A or B. And you probably guessed that we can also then visualize the intersection of two sets. That is to say, that kind of football-shaped area that lies within A, and it also lies within B. And that contains all of the elements within the intersection of our two sets. And of course, the other operation that we can perform on sets is the complement. And the complement of A, represented again by the name of our set with a line above, is represented by the region completely outside of our set A. Remember, the complement contains all the elements in the universe that's inside the rectangle, but outside of our set, or in this case, outside of our circle. So let's create a Venn diagram that represents the relationship, the complement of A union complement of B. So we'll start with a rectangle, that is our universe, and since we're dealing with two sets, A and B here, we'll have two circles, and we usually draw them overlapping unless we know that they're completely disjoint or not overlapping. So we'll label the one on the left our set A, and the one on the right will be our set B. Now, we want to shade the region that's represented by the complement of A union the complement of B. So if this is set A, then it's fair to say that this region, everything outside of A is going to be the complement of A. So I'm going to shade that in, and we're going to stay outside of A. And so I've used green to represent the complement of A. Now I'll use blue to represent the complement of B. And so that will be the region that is completely outside of set B. So the union of these two sets will be all the elements that are outside of B joined with all the elements that are outside of A. That is to say, everything that is green joined with everything that's blue. And I'll do that more carefully. We'll do this one in red so that it stands up. The union of these And so everything outside that little football shape in the middle will be the complement of A joined with the complement of B. Now the follow-up question is there another way to represent this red region, that is to say everything outside of the overlap? Well, sure. I mean, if we were to define the overlap, it would be the intersection of A and B, right? So the intersection of A and B would be represented as A intersect B, but we don't want the intersection. We want everything outside of the intersection, or in other words, we want the complement of that. So we could conclude here that the complement of the intersection of A and B is the same as the union of everything outside of A and outside of B. And this is kind of one of the first times we're going to see a property or a different way to represent the same set of elements. Let's take a look at another example. Let's create a Venn diagram and shade the relationship represented by the complement of A union the complement of B union C in parentheses. Well, we obviously have three sets within our universe here, so the universe is everything within the rectangle, and we have set A, which we'll put in the bottom left, B, which we'll put up here on top, and C in the bottom right. Okay, so let's start with the complement of A. I'm going to shade the complement of A with green. Everything outside of A will be in green. Now, what we have in parentheses is the complement of B union C. So B union C would be everything in B and C together, but the complement of that will be everything outside of B union C. So I'm going to shade that in blue. All right, but what we want to shade is the union of everything not in A, the complement of A, and the complement of B union C. So like our previous example, I'm going to shade in the union of the green and the blue with red. Okay, so everything outside of this little shape will make up the subset of the universe defined by everything outside A joined with everything outside B union C. Now, is there another way that we could represent this relationship, everything outside of that? Yeah, there is. We could say that we're combining everything outside of A intersect B and or intersect with everything outside A intersect C. And that's another representation for our shaded red area here. Now, it's important to note that that's not the only other representation. There may be others and some that are even simpler, and that's going to be the focus of some of our work in a future lesson. Let's do one more example, and then I'll give you one for practice. Let's create a Venn diagram to illustrate the relationship shown here. A union B intersect A union C. Well, once again, we have three sets, so we have to have a rectangle to represent our universe, and we have to have three circles to represent our three sets. Again, I'll put A in the bottom left, B in the top center, and C in the bottom right. Now let's start by shading the region represented by A union B. And I'm going to shade that in green. A union B are all the elements of A and B combined. And there's A union B. Now we also need to shade A union C, and so I'll represent that in blue. And finally, we want the intersection of these two, so we want elements that are in A union B and in A union C. So I want to shade in red and all regions that are part of both of those. So that's going to consist of all the regions that contain blue and green. And there's the region defined by our criteria. Now, can we represent that relationship in another way? Yeah, actually we can, and we can represent this one a little bit more simply. Most of that region is defined by A. The set A includes almost everything that we have in red here, so we could say that it's A, joined with this little region over here though. So how can we define that region over here? Well, we don't have to limit ourselves to just this little tail that's sticking out. We could say that it's everything in A with the football-shaped intersection of B and C. So we could call this A union, A joined with the football that is B intersect C. And there's another representation of the same subset. Okay, you do this one for practice. Create a Venn diagram to illustrate the relationship shown here. The complement of A union B intersect C. Now before you get started, just so that our results are easier to compare, let's use the same set labeling system. Have a rectangular universe, sketch that on your paper. Sketch three overlapping circles. Keep two on the bottom and one on top just so that the orientation is the same. And let's just agree that we'll put A in the bottom left, B in the top center, and C in the bottom right. Now go ahead and make your Venn diagram and unpause when you're ready to see if ours match. Okay, let's start. The first region that we need to shade is the complement of A, everything inside our universe but outside of A. And I'll do that in green. Now we want to have a union of that region with the region defined by B intersect C, and so I'm going to shade B intersect C in blue. Now the union of these two will be the region that contains either green or blue. All the green region joined with the entire blue region. Okay, so there's our representation. It's everything that's shaded in red. That's everything outside of A, along with everything inside this center triangular region, which really has no simpler representation or no good other alternative ways of being represented than the one that we have here. Okay, can you determine what set is being represented by the Venn diagram shown here? If you were to just describe this region in words, you'd say that we're within set B, but we're also outside of set A. So if we describe that as a set, we would say that we're in B and we're in the complement of A. So writing that out, we would say B and, but the and condition is represented by an intersection. We also have to be in the complement of A. So we would say B intersected with the complement of A, or in other words, we need to be within B and we need to be outside of A. You give this one a try for practice. See if you can describe the region that's shaded in our Venn diagram here. Unpause when you're ready to see the solution. Okay, well, the region that we would start with, it looks like we're mostly in the union of A and B, but we also have to stay outside of set C. So we'd start by describing the union of A and B, but we need to be in A or B, and, so again, we're going to use an intersection, and we have to be in the complement of C. We have to be outside of region C. And there's our representation. We're in A or B, and we're outside of C. Here's one more. This one's a little tricky. See if you can do this one. See if you can use sets to describe the shaded region in our Venn diagram here. Okay, well, we could break our shaded region into two main parts. We've got the complement of B, everything outside of circle B, but then we also have this region on the inside. So let's start by describing the whole region outside of B. That, of course, is going to be the complement of B. But we want to add to that, so we can be outside of B, or, that is to say, union. We can also be in this center region right here. This triangle in the center where three sets intersect is called a rouleau triangle. So we have the area outside of B and this rouleau triangle in the middle. But we don't have to define just this triangle. We could more simply describe it as the intersection of A and C and include the entire football region. So we can finish our description by saying we're in the complement of B joined with the intersection of A and C. And there's our description outside of B or in the intersection of A and C. Now there are other ways to describe that region, but none will be simpler than that. Okay, let's wrap up this lesson by taking a look at one more type of problem. Let's determine the elements that belong in each of the following sets. First one, A intersect B. Okay, so if we look at the place where A and B intersect, we can see that there's only two elements in there, and they are 3 and 5. And so we would say that A intersect B consists of the set with elements 3 and 5. And that's all we can do there. Our second one, the complement of B. Well, the complement of B is going to be everything outside of set B. So everything outside of the circle that represents set B, that's going to be all the numbers shown except for 3, 5, 4, and 8, which are in set B. So if we list those in order, we would say that the complement of B consists of 0, 1, 2, not 3, 4, or 5, 6, 7, and not 8, but 9. This Venn diagram has a total of 10 digits. That is to say, our universe contains 10 elements. And since 4 of them are in B, we should get 6 that are not in B, and that's exactly what we have here. The 6 elements in the complement of B are 0, 1, 2, 6, 7, and 9. And our last one, we want to find the complement of A union B. Well, let's start by finding A union B, and then we'll find its complement. So A union B will consist of all the elements that are inside of A or B combined. Putting those in order, we have 2, 3, 4, 5, 7, 8, and 9. But we want the complement of that. We want everything in the universe except those numbers, and so we would say the complement of A union B is everything outside of A union B, and we can see that those are 0, 1, and 6. And we're done. Okay, one more for you to do for practice. Determine the elements shown in each of these three using the Venn diagram on your screen. Go ahead and do those and unpause when you're ready to see if you have those correct. Okay, our first one, B intersect the complement of C. So we need to stay inside of B, but we also need to be in the complement of C. And so we need to be outside of region C. So if we're inside of B, and in the complement of C, that's everywhere outside of C, then apparently we need to stay in this region out here. And so the elements in this region out here are 4, 6, 9, and 12. We could have taken a slightly simpler approach and said that we need to be in B and not in C. So the B elements would be the 7 that are listed here, but we have to be outside of C, so that removes these 3, leaving us with 4, 6, 9, and 12. Our middle one, A intersect B, intersect the complement of C. So here we need to stay in the intersection of A and B. That's going to be these 3 elements right here. But we also need to be in the complement of C. That is to say, we need to stay outside of region C. So if we need to stay in the intersection of A and B while also staying in the complement of C, that pins us down into this region right here, which consists only of the numbers 4 and 9. And again, more simply, we could say we need to be in A and B and not in C. So we're in A and B, but not in C. 4 and 9 are the only elements that survive. And our last one, the complement of A union B union C. So we'll start out with B union C. B union C will be everything inside the joining together of sets B and C. And then we want to join that with A. And so in green, I'm representing A union B union C. But we want the complement of that. And so the complement of A union B union C will be everything outside of that. And so that'll be everything outside of the union of those three sets. And we can see that that will consist of the elements 1, 8, 10, and 14. If you got all three of those, you're in good shape. If not, you might want to rewatch those explanations and some prior examples to make better sense of what's going on here. Okay, well that wraps up this section on Venn diagrams, and it also wraps up our work on sets and operations with sets. But we're going to use a lot of those very same ideas when we start working with logic and logic statements in our next unit. So go ahead and do the homework for this section. As always, make sure to let me know if you need help. This is also a topic you can get help with at the Math Center, so don't hesitate to reach out there if you get stuck on any of the assignment problems. We'll see you in the next lesson.